first arrived at the lake in August of 2016 on Antelope Island, and I remember driving around with my advisor, Dr. Gary Bolofsky, and at one point we got out of the car and we walked along one of the shores of Antelope Island, and as we were walking, I remember seeing and hearing, like I am now, all of these adult brine flies. And as I approached the actual water's edge, I remember looking down and seeing all of these tiny brine shrimp just glimmering in the sunlight. And then looking a little further out into the deeper water, I remember seeing these bumps, these irregular, just interesting bumps sticking out of the water. And my advisor pointed at those and said, "See, those are the microbialites." And from then on, I was hooked on understanding the food web ecology of the Great Salt Lake. My name is Katherine Barrett. I am a third-year PhD student in Dr. Gary Bolofsky's lab at the University of Notre Dame. And I'm studying benthic pelagic linkages in the Great Salt Lake. All right. So Great Salt Lake contains two distinct energy pathways or food chains. We have the benthic food chain, which is on the bottom of the lake. It's composed of the aquatic life stages of the brine fly and microbialites, which are reef-like structures that contain very abundant microbial communities that form an important food source for the brine fly larvae. And then there's the pelagic food chain, which is composed of the brine shrimp, which feed primarily in the water column on algal food resources such as phytoplankton. So while brine shrimp primarily feed on phytoplankton in the water column, brine shrimp over the summer months, their population becomes so abundant that they actually overgraze their primary food source. And this introduces a bottleneck to shrimp production in the lake and fall cyst production. We think during the summer months, like August, when phytoplankton densities are really low, that brine shrimp will actually switch from the pelagic food to benthic food, and the food chains would be linked. So to investigate this, my research involves seasonal field sampling of microbialites throughout the south arm of the Great Salt Lake, as well as laboratory feeding experiments. And what I really love about field sampling is I get to come to Bridger Bay 3 times a year, early summer, late summer, and December, to try to capture the seasonal dynamics of brine flies and brine shrimp, because I'm collecting shrimp that are occurring directly above microbialites, taking them back to the lab and trying to look into what they are eating using different methods. So the Doyle Stevens Scholarship is critical for my research because I'm interested in understanding, so if microbialites are important to the ecology of brine shrimp, then I need to find out what brine shrimp are eating in the lake during different times of the year. And one method that I'm using to determine this is a molecular approach, where I'm taking brine shrimp that I've collected from various sites in the Great Salt Lake, including Bridger Bay right here, and I'm taking out their guts and sequencing all the DNA present in their gut contents. And doing this will allow me to identify to a very high resolution of what they're actually consuming in the lake, and if what they are consuming corresponds with what is present in the water column or what is contained on microbialites. So the Doyle Stevens Scholarship is providing me with the ability to continue that avenue of my research. And another aspect of the DNA sequencing that I think is really important is I'm not only looking at what is in the what the brine shrimp are eating and what the brine larvae are eating, I'm also going to be determining the microbial diversity contained on microbialites from various regions of the South Arm. And this will hopefully contribute to the growing literature on just the importance of microbialites as these structures are only found in a few places globally. And I feel very fortunate to be working in Great Salt Lake, not only just because it's just such an inspirational place, but it's such a large system, and it contains the largest known expanse of microbialites in the world. So those bumps in the water that I first saw in August 2016 during the record low water levels, they're not just bumps in the water, they potentially could be the missing link to brine shrimp persistence in the lake. And not just that, but when you go to the lake, and like right here I see and I'm hearing the gulls and the grebes. These birds, which attract many visitors from around the world, rely on a steady supply of prey items, which are the brine shrimp and the brine flies in the lake. And so to further our understanding and protection of this valuable ecosystem, which is increasingly threatened by just global change, we need to understand the multiple energy pathways that are fueling the prey that the birds are relying on. This is an exposed microbialite, and one of the features of some microbialites that are found in the lake are these distinct layers that you can see. And all of these surfaces likely once contained abundant biofilm, like you see here in this living microbialite. But this one's exposed due to lower water levels. And Great Salt Lake, we are facing just an intersection of multiple anthropogenic stressors to the lake, including increasing water diversions, which could put microbialites at risk. Because with lowering the water levels, salinity increases, and we are still learning on how microbialites will thrive in increasingly saline waters. And what are the implications on the brine fly food chain and the brine shrimp food chain? Because if it turns out that brine shrimp really do depend on microbialite food resources during times of the year where they can't access the phytoplankton, then this is really important, because we need to understand just the multiple energy pathways that fuel the prey items, the brine flies and the brine shrimp, that ultimately the many avian species that visit the lake each year depend on. So I hope that my research, which involves just identifying microbial diversity on microbialites and understanding what the brine shrimp are eating, I hope that that can contribute to our appreciation of the benthos and hopefully inform wise management of our very important Great Salt Lake. Where was I? Oh yeah, so bloopers, yay!